Hey students, and welcome to today's live session when it comes down to TCS digital programs. So let's go ahead and continue where we left off. So this is another live session that we're gonna have with a very interactive way where we will be going through a lot of programs that can often be asked when it comes down to either TCS digital or sometimes TCS NQT as well. So let's go ahead and start this off. So just to begin with, in this live session, I will be going through the chat window of the YouTube video. So if you guys have any questions regarding the programs that we're going to go through, any questions regarding all of these, you guys can feel free to ask. Do not hesitate. I will ensure to answer whatever question it is regarding these programs that you may have. Now, let's begin without any delay. In the last session, we went through this particular program where we started to work on a couple of live or a couple of programs on T9 solutions. That is, we had a T9 keyboard problem. Where within that T9 keyboard problem, we had, let's say, I'll just take this simple scenario for us to understand, where we had a T9 keyboard, where we know in a T9 keyboard, wherever you have 2, it is A, B, C, wherever you had 3, it is D, E, F, wherever you have 4, it is G, H, I, and so on. And if user presses something like 2 and 4, that means user could have pressed any combinations of these. User could have pressed something like AG or AH or AI or even BG or BH or BI or even CG or CH or CI. So these are the 9 possible combinations that user could have entered when they press 2 and 4 as numbers in a T9 keyboard. So the problem given to us is user is going to press some numbers up to 4 or 5 digits long between 2 to 9. So in the last session, this is the problem that we solved using C++. So I'll just take this as T9 keypad, one image, so that I can quickly show you how exactly we work through this. I'll just take this image very quickly so that we don't have to take up too much time. So this is the exact image we took last time. So for those who haven't gone through this problem yet, one thing that I would also suggest is please go through our previous video where we have solved this particular problem. Now, in this scenario, if user, let's say, presses 2 first and then 8, if these are the 2 digits user presses, then the possible characters that user or possible values user may enter are either AT, AU, AV, or BT, BU, BV, assuming that user is pressing 2 first and then 8. And similarly, CT, CU, and CV. So this is the output we need to write if user is pressing 2 and 8. Similarly, if user presses something like 2, 5, and 8, we need to likewise calculate and show the output accordingly. Like if 2, 5, 8 is pressed, there are going to be 27 possible combinations, because 3 times 3 times 3, total 27 combination of different character combinations. So that's exactly what we need to do. And just to show this, we have already done this in C++. Let's compile this and let's run this for our reference, just so that you're all clear with this. Let's say if I enter 2, that means the possible combinations are only A or B or C. If I enter 2, 8, as pointed out, it is A followed by TUV, or B followed by TUV, or C followed by TUV. Similarly, you can also have multiple characters like 2, 5, and 8. That will give us 27 different combinations. So we've already solved this in C++. In this session, we're going to go through the same problem and try to solve this in Java. Now, for us to solve this in Java, the first thing we need to do is create a class which is public, and the class name should always reflect the file name. So we're going to call it code, And within this class, we're going to do this simple task where we're going to create our main function, void main. I have one question. Yes, it is the same problem, but we haven't solved it in other languages because when you go through, let's say, different programming languages, the data structures you use will have different functions associated with them. The data structures you use will have different combinations of features associated with them. So we need to take a look at them, see how to solve using them. So that's exactly what we're doing. Because I can understand that every student may not want to solve the problem only in C++. Some may be more familiar to do it in Python, some may be more familiar to do it in Java. Since we've already learned how to solve this problem, we're just going to convert the already available code with us into Java and Python very quickly, and we're going to move ahead to our next alternating series problem. So let's go ahead with this and let's try to solve this to begin with. So here, let's begin with this. So kindly hold on, guys. Alright, so let's go ahead and solve this as soon as possible. Now, the first thing is we're going to have to read a string. As we have done earlier, we're going to have to read a string input which we then have to send to our T9 permutation function. So let's read a string as input very, very quickly. So the difference here is when we want to read a string as input in Java, the logic is slightly different than C++ because in Java, strings are gonna be based on its own class and every class begins with uppercase. So even when we write string args, we write again with uppercase over here. So everywhere when we work through Java, we use uppercase over here. Let's always remember that. So I can just use something like string str. We're just creating a string, and this is the string where we're going to store, let's say, our input. So to read input, I'm just going to use a scanner object, new scanner of system.in. Now here I'm just going to give, or we're just going to import java.util.star over here, done. Now we just need to read this string. Let's take string equals scanner dot next line. Now that's done. Once it is done, we're going to immediately call our T9 permutation function, same as what we did before, by sending the string. So we're going to receive the string here. Let's make a static void T9 permutation function where we are receiving a string. Now, there are two ways in which you can expect this question. You can expect this question where only this function is given and you have to write the output, or where the entire program is to be written by you. So, since if you write the entire program by yourself, you may or may not want to do a function because you're only performing this once. You can write it here. But if you get such a question, how to receive in function and everything, that's why we are going through this scenario where we are receiving it in a function and working through it. So let's take a look at this. If we get this function, how we're going to solve it if Java is the preferred language of ours. So the logic is very simple, not to worry. It's the same as what we have done. So we're just going to have to take the exact same logic as before. We're going to take a string here and create it here. That's it. Same string for our reference. And this string, I'm just going to make sure that I'm not going to specify the size. You can write it before, after, up to you. But I'm just not going to specify the size here because it's just an array and we are creating in the same line. So we don't have to specify the size specifically or separately over here. Once this is done, the first thing I'm going to do is use the same logic. We're going to create three variables and we're going to find length of string. Now remember, most functions remain same. If you want to find length of the string in Java, also you have the same function. In C++ also you have the same function. But if you want to create a queue, the logic differs. Let me just point this out. Let me ask all of you one question. Whenever I want to insert and delete elements, insert and delete a lot of elements, which is more efficient to use, arrays or queues? What do you guys think? Sorry, not queues, arrays or linked lists. What do you all think is more efficient? When I want to insert and delete a lot of elements, think of this. If it's an array, 1, 2, 3, 4, and 5, if I want to delete one, I have to move all the other elements behind because 2 must be in index 0, right? I have to move every element behind. But in a linked list, if I want to delete one element, let's say if I want to delete one element in linked list, I just have to remove the first element space and take the starting address of second element and store it in my starting address. So simple logic. It is linked list which is better when we insert and delete a lot of elements. And here in our example, in our program, we do perform lot of insertion and deletion. As rightly pointed out by three of you, we will be using this particular concept that is called linked list to perform this. Now, since we're going to be inserting and deleting a lot of elements, as you guys remember, once I have A, B, C, I need to delete them and then have something like A, T, B, T, C, T and everything. So basically we are adding a lot of elements over here. When we are inserting and deleting, it's better to use linked lists. It's easier. So we're going to have to create a queue of linked list, not of array. We're not going to create an array of queue. We're not going to create or implement a queue using arrays. We're going to implement a queue using linked lists. So there's a specific code to create a queue using linked list when it comes down to Java. Now, remember this. We need to create a queue of string. So string also starts with uppercase S. Let me see if I have imported java.util.story. Yes, because this queue and system scanner, all of this belong to java.util. That's why I'm importing basically everything. So I'm going to create a queue of strings. I'm going to take the same name as we did before, called string underscore queue. But this time I'm going to have to write it equal to linked list of string and the constructor. So I'm creating a linked list of string, and that linked list, sorry, I need to use new keyword. I'm creating a linked list of string, and that linked list of string, whatever we have, we are storing it in a queue. If you're a little confused as to how we are storing linked list into queue, don't worry. You can go to Java docs and go for queue. You can get a really good idea on how exactly this works. If you're really a bit confused with this, do not worry. Here they have written which is implementing classes of which can extend what. So you can get a really good idea of this. So all that we are doing over here is just creating a linked list queue. That means it's just a queue of strings, but this queue is created using linked lists instead of arrays. For now, you can just assume it like this. Now, what's the first thing we did earlier? We pushed empty string over to the queue. Now, we don't have push function here. Instead, we have add function in Java. So, functionalities change a little. That's one thing we should know. In each language, functionalities change. So, that's something we should be very, very familiar with. So, whenever we move language to language, we should remember these little changes. Now, for us to make it easy, I'm going to take the rest of the code directly, copy it. Let's not take the rest of the code entirely. I'm going to take this whole for loop first. Copy it over here. So I have this for loop where for each of the input number or for each of the input digit, we don't call them numbers, so we call it as for each of the input digit. What we're doing here is going through the queue and finding the size of the queue initially. So whether it is C++ or Java, queue size function is the same. We don't have to worry about that. Now after that, we're going to store whatever we find over here, string of I minus 48, whatever we get, into another string. And since in Java, every string starts with uppercase because it's a object of a class, whatever we're creating here is an object of a class called string, and all class name starts with uppercase in Java. Now here's the problem with Java. Whenever you use string, see, string is different from character array. String, if you create string str, let's say for example, I'll just show you this very quickly. If you create string str, this is an object of class string. If you use character str of 10, this is an array of characters. Whenever you have an array of characters, you can use index. But when you have object of a string, you cannot use index because it's an object. You can't access index. Index is only for arrays. So here, if you want to access any index, we need to use a function from this object. The function we have is character at. So in Java, every function begins with a lowercase and second word of the function always begins with uppercase. So we have something like this, character at function. So we're going to do the same thing over here. So we're going to use, let's say very quickly, something like str dot character at I instead of this. So let's go ahead from here over to the next case. We've solved this part. Let's go on to the next one. The rest is the same. We don't have to change anything except here. We need to make some changes here. In queue within Java, we don't have the function push. Instead, we have the function add. Similarly, to get the first element of the queue, we don't have the function called front. To get the first element of the queue, we need to use the function called peek. So there are a few changes which come up in C++ and Java. We'll only be able to very familiarly understand this when we go through the same over time. So here, let me ask you guys one question. Will this work or should I change anything here? This is my simple question to you guys. Will this work or do I need to change anything over here? Current underscore string is an object of string. Since it is an object of string, can I access index here? What do you guys think? Can I do this or should I change it to something else? Think through. This is an object of string in Java. Object of strings cannot access indices because they are not arrays. So what should I change this to? Any guesses? So, alright, I'm getting a few different answers. Alright, let's see back to this. Let's go back to this. Here, str is a string, right? Str is a string. Now, in this string, of course, absolutely right, as one of you pointed out, we can't use index, we need to use character at function. Absolutely right. So even here, I can't use index j. Instead, I need to replace this as dot character at j. That's it. And one more difference is we can't use pop function as well. There's no function called pop within this queue. Instead of pop, we have a very different function that is called remove. So we just need to change that as well. Once we have done this, we've got our entire program sorted till here. But after this is done, we need to print the queue, right? At the end, we need to print the queue. To print the queue, we have a special easy method, very easy method to do that. Because in Java, we have something called for each loop. So for each string called element within our string queue, we're just going to print element. That's it. So we can use for each loop like this, where we are going through each character, each string, each element of string type within our string queue. This is a for each loop which we can use and print the entire queue using for each loop. So it automatically iterates through it. So we don't have to worry about it at all. So let's see if this works. I'm not sure. We may have some errors. We may not. Let's see if it finally works. Let's try compiling this. This is a Java code. So we'll compile the Java program. And let's try executing this. So I have one little error, of course. See guys, in Java, I cannot just use while of queue size. I need to perform comparisons. I need to say that as long as it is not equal to 0, I cannot just write one value. That is not possible in Java. So let's compile. Now there's no error. Let's execute it. Let's give just one input to. It's giving me ABC. Let's give two inputs as 2, 8. It's giving me 9 values as expected. A followed by TUV, B followed by TUV, and C followed by TUV. Let's try one more thing. Let's give 2, 5, and 8. So we're supposed to get 27 different values, which if you calculate, we do get exactly. Because if you remember, the height of this is 26 rows. We're getting 25 rows. We're getting 27 completely. So we got this done. So our Java program is also pretty clear for us. So I'm just going to copy all programs for us. So this is our C++ code initially. And this is our Java code followed by this. Done. Now, let's quickly try to convert this to the most easiest programming language possible. According to most of us, that's going to be Python. So for me to convert in Python, pretty simple. Again, we just need to read a string and call a function. So very simple logic. I'm just going to read a string. Done. That's it. Just one line. No need to worry about anything else. We just read a string and call T9 permutation of str. That's it. So here we're going to create a function called define T9 permutation of. We're going to read the string. And we're going to have to go through the entire logic here. Now the first thing again as before is we need to create this array of strings. Now we don't have an array concept here. We have to create a list instead. We can't create an array. Instead we're going to end up creating a list called T9. That's it. So if you want to access something from here, you can try printing something like T9 of 2. This is supposed to print A, B, C on the screen. Let's see if it works. Let's just give it a try. Python 3, let's give code.py, just a run. I'll give some string. It doesn't really matter. We are getting index 2 value perfectly. So we have created it as a list. Now, just to point out, the moment we are done with this Python program, we're going to go for a very important program up next, which is, as far as we have seen, very commonly asked in interviews. Very, very commonly asked. That is called alternative series problem. So let's try to complete this quickly so we can go for a hugely important program up next. So let's give this a quick try and see how exactly this works. Now we have read this. Now let's go ahead and go for the next scenario. Now we need to read our string, which we have already read. We need to read the length of our string into n, and we need to create a queue. Now again, as always, the only thing I'm going to do is just convert the already available code into Python. We're not going to take too much time to go through the logic entirely because we have done that. We have already completed it. Because I understand that we all are waiting for more and more programs to understand more logic. So let's try to go through programs as quickly as possible since we have already gone through the logic here. So let's give this a try. So we need to first find n, which is length of the string. So I'm going to write n equals len of str. Just a few change in functions. That's all we'll have, nothing else. Now I need to create a queue. To create a queue in linked list, remember, to create a queue in Python, remember, there's no special thing called queue. I just need to create a queue as a list. That's it. A list itself will be a queue here. We have to use list itself. We have really no other option, no other choice. We're going to use a list itself as an empty queue. And we're going to add an empty string to it. Instead of adding it later on, we can add directly here. That means there's only one element in this queue. That one element is our empty string. So all these two statements of code, we have just combined it into one statement here. So once this is done, let's go on for the next one. We are going through a loop that is for each input digit, for each input character of string. So we can go for I in str or for digit in str. We can do it multiple ways. Just so you guys know, if I go through for digit in str, we'll go through each digit in string str, or you can also go for I in range of 0, n, and you can access each element as str of I. We can even do this. So let's do this itself. Since we have already done this, let's not change the code, which is easy for us to implement since we have already gone through this. So for loop which ranges from 0 to n minus 1, and in this for loop, first we are finding the size of the queue. After finding the size of the queue, we are taking the current string like this. Let's see how we're going to convert this into this code. Now this is where I'm going to ask for your help. We're gonna assume that I'm not good at coding. All right, that's what we're gonna assume, and I'm gonna take your help. So this is where you will be like my programming guide to write this. Now, if I want to create queue size, I just need to use again. Sorry, this should be our queue name is string queue. That's what we have named. Let's update that. So I just need to use again length of string queue. That's it. No dot size function, nothing. We can just use length of string queue. Done. Now we need to create one more string here, which is going to be t9 of string dot character at I minus 48. Now there's a little change that we need to do over here. In Python, we cannot use dot character at or anything like that. We have to go back to our previous range. In string, if string is 2, 5, I need to access index I. I is 0 or 1. Initially I is 0. If I want to access index I just need to use str of I. That's it. That's all I need to do. But here the condition is I need to convert it to a numeric format and subtract 48 and use that as the index in T9. To convert it to numeric format, we have a couple of functions in Python that is called ORD and CHR. CHR converts number to ASCII character value. If you use a number like 65, it gets converted to ASCII value A. In ORD, if you use ASCII character, it gets converted to number like 65. Since we need to get number of str of I, whatever is in str of I, it's currently a character. Since we need to convert this character to number, I need to use ORD function. That's exactly what we're going to do here. We're just going to use ORD of str of I. This means str of I is taken. I initially is 0, so str of 0 is 2 as a character. This character, whatever we have, we are using ORD function, wrapper function to convert it to the number 2 instead. That's basically what we're doing. So once we get to convert it to the number 2, number of it as 2, its ASCII value. ASCII value of 2 is 50. Since we convert it to the ASCII value of 2 to 50, we just need to subtract 48 to get the actual value as 2. That's all we're doing here. Simple logic. So let's quickly do this. Once we do this, we'll get some index like 2 over here. I have one question. We could also use int. Absolutely right. You can also use int here, which ensures that you don't have to do this as well. So we can make a lot of different changes because Python has so many functions. Python has such a huge amount of functions that you can use where you can convert to many different ways. So we can take str of I, which is going to give us 2 as a character or 2 as a string because there's no concept of characters here, and directly convert it to integer. So we can avoid additional subtraction here. This can also be very easily done. So glad to see that you guys are going through more and more functions. This is something that can be very easily done. So once we do this, we'll go to this while loop. That's exactly what we need to do. I'm just going to take this whole while loop, copy it here. rather than copying it here, let's just run it. So let's not worry about it. So the condition is while queue size is not 0. So I can give something like queue size not equal to 0. So as long as queue size is not equal to 0, if you want, you can also use brackets. It's a better habit for us to do. That's it. We're just going to use this. So as long as queue size is not 0, what we're doing here is going through each character of current string length. So you can do something like for j in a range of 0, comma, length of current string. For each character from 0 to length of current string, you can either do this or you can do something like for character in current string. This will iterate through each character of current string. You can directly use character instead of using current string of j or something like that. So we can do both. It's completely up to our choice because both will do the exact same thing. One will internally take the index, other will externally take the index. So both have the same thing. Now, here's what we need to do. We need to find the first element of the queue and we need to append with the index j. After appending, we need to add to the queue. So first thing I need to do is find the first element of our string queue. How do I get to know first element of string queue? There is string queue of 0. That's it. We can directly access index 0, right? Because it's a list. Since it's a list, I can directly access index 0, which is going to be the first element. I need to add to this current string of j. Whatever I add, whatever result comes, this result I need to add to my queue. So I'm going to use queue dot append of these values. So simple logic. We're going to take the first element of our queue. We're going to add each character of our current string, append it, add it as a string, and then add it to the end of our string queue. Once this is done for each of the I value, each of the value, each of let's say the value within queue size, we need to remove the value in the queue. We need to remove the first value in the queue. Now, how am I going to remove the first value in the queue? Simple. I need to use pop function. Since I need to remove first element of the queue, I'm going to use a simple logic here. str underscore queue dot pop of 0. I'm just removing first element. That's it. Nothing else. Very simple logic. Append to add, index 0 to access first element, pop of 0 to remove first element. That's it. This is how we work through lists in Python. Then I need to reduce queue size. The problem is in Python you don't have increment decrement operators, so you need to use queue size minus equals 1 by yourself. That's it. Once that is done, this entire code is done. Then we have to print the entire queue. To print the entire queue, remember we need to print the entire queue one element at a time, one line at a time. We shouldn't print everything together. We need to print one line at a time. So if I do something like this, print of string queue, it's going to print all the elements together separated by comma. I don't want to do that. I want to go through each element and print. So we can use for element in string queue, we can print elements separately. That's it. This is our entire logic. Sounds like a simple logic, right? So if you see in our C++ program, we did something like how many lines? Something like 29 minus 7, 22 lines over here for the function. In Java, we ended up doing how many lines? From 26 over till 6, very similar, something around 20 lines. Whereas in Python, the entire function was only 14 lines. So we basically reduced the number of lines to nearly half. So let's try compiling or interpreting this. Let's see if something goes wrong. Okay, it went right. Let me just give 2. For 2, I got A, B, C. Let's try one more value. I'm going to give 2, 5. I got all the values. A followed by JKL, B followed by JKL, and C followed by JKL. Similarly, if I try something like 2, 5, 8, I should get the same amount of values over here as well. So we got our entire program solved even in Python. So this is our entire program, the same exact program, the same T9 problem when we work through this in Python. So we have solved this particular program in C++, Java, as well as Python. So with this done, I hope it was very easy enough. You guys can let me know if you found it easy enough or you found it too difficult, whatever it may be. So this is how you can also know that we use Q to perform breadth first search. So I have one question. Could you brush up through the logic in 1 minute as a recap? Sure. Very shortly, I'll do that. See, the logic is like this. First thing I'm going to do is create an array of index 0, 1, 2, 3, 4, so on up to 9. So 0 and 1, whatever you store, it really doesn't matter. From 2, you have to store A, B, C, D, E, F, G, H, I, and everything, because if I press 2, these are supposed to be printed. If I press 3, these are the possible values. Similarly, W, X, Y, Z for 9. So what I need to do is, if user types 2, 5 as input, I'm supposed to print the output as all the combinations, like A followed by, or instead of 2, 5, I'll take 2 and 4 because we have written here. So A followed by GHI, then B followed by GHI, then C followed by GHI. So to do that, here's what I'm doing. Initially, I'll create an empty queue, which is only going to have one element, that is an empty string. There's no space here. It's an empty string. So what I'm going to do here is take the first integer, first character of it. Whatever is the character, I'll go to that index in my string. That's what we are doing here. Whatever is the character, we'll go to that index in our T9 table. Whatever is the character, we'll convert to integer, go to that index. In that index, we get ABC. So for each value of ABC, what we're going to do is, for every value of Q, how many values do we have in Q? Only one. We'll remember this. For this one value of Q, we're going to multiply it with all the three values representing 2. So what are the three values? A, B, and C. Let's add this empty string. We get A, B, and C as expected. That's it. Once we added it, once we appended it, whatever was our initial Q, our initial element, we're going to delete that. If we delete it, our Q only has this. Done. Sorry guys, hold on. So I'm unable to move these. Okay, perfect. So once this is done, now let me look at the size of the queue. The size of the queue is 3. Do I have any more in element? Yes, I have one more element. So I need to go through 4. When I go through 4, I get GHI. So what I need to do is multiply each one of these 3 elements with G, H, and I. I'm going to take the first character A, I'm going to multiply it with GHI. That is for each character in Q. That is why I'm using while Q size not equal to 0. I'm keeping a track of Q size as 3. Until it becomes 0, I'm going to repeat this. And until it becomes 0, I'll take each element of the queue, first element of the queue at a time. First element of the queue only, and then remove it. Then first element of queue, then remove it. Then first element of queue, then remove it. What do? I add it with all characters of current string. All characters of current string is GHI. So let's multiply A with them. I'll get AG, AH, AI. Once this is done, I'm deleting this element. I'll only have this much. Q size is reduced to 2 now because I only have 2 elements left. B also, I'm going to do the same, multiply with this. I'll get B and G, B and H, and B and I. Done. Now this element also will delete. Now the size of the queue is down to 1. That means only one element left, C. Let's multiply C with everything. I'll get CG, CH, CI. Once this is done, we got our final set of values. Sorry guys. Yeah. Once this is done, all elements here are also done. Queue size is also empty. Now the entire thing is done. Whatever is the left out final Q values, that is what we're going to print. That's all. This is your entire logic. I hope that sounds simple enough. So with this, I hope it's been clear. I just want a few of you or all of you, if possible, to let me know if you found this program to be easy enough. This is a program that was found to be very difficult to answer. Out of let's say every 100 students who attended this, the success percentage was something around 31%. submitted the program successfully. So basically, you can say only 1 out of 3 programmers were able to submit this successfully. I hope in this session, in our case, you have found it easy enough. You have found it very easy to work with. So with this, shall we go on to the next program? So by the time you guys can just put one text if you're comfortable enough with this program. I hope there's no confusions because we are ensuring that we're having a very interactive live session via YouTube so that you can communicate directly and get your questions answered by us as well. So I really hope for everyone joined up. This program's been easy and simple enough. You guys can let me know for sure whether it's been easy or slightly difficult or very difficult, whatever it may be. Do not hesitate. If you want to go through the video again, please do that to make sure you get to understand it better. I'm glad to hear that a few of you are getting to know this very, very well. So very glad to hear that. Now, let's go on to the next program. This is a series program. Now, we are moving away from something based on a string program. We're moving away from strings back to series, back to numeric series. So very glad to hear that many of you are finding this easy. Very, very glad to hear. So let's go ahead with this series of numbers. So this is how we get the series. I'll just show this to you guys. So guys, let me just modify this. So again, very glad to hear a lot of good responses. Very, very happy to hear that. So this is your series, and the question is to find nth term of the series. This is your input series, and all that you need to do is find nth term of the series. How are we gonna do this? Let's take this scenario. I'll take these indices. I want you guys to come up with the logic. Let's see how many of you will be able to. So this is our series. User can ask like the online compiler may ask like find the 10th term or 20th term or 50th term, any term of the series or something up to 1000, 10,000 or something like that. So how are we going to figure out some nth term of the series? So think through, what series does it look like? I have one question. Can we do in Python? In TCS, people say it will not give correct answers. See, here's the thing. You can choose any programming language you like. You just need to ensure that you're printing the output in the same exact way that the compiler is expecting, or in the same exact way that they are expecting. I'll just give you this simple example. It's not about which programming language we choose. It's all about how we are printing the output. So by the time you guys try to figure out this series, I'll just give you the answer for that. See, here, take this scenario. If you print the list as it is in our previous program, if you print instead of each element, if I directly print the queue, here's what happens. If I run this and give 2, 5, this is how the output comes. Now, according to the program, according to the online compiler, it may consider this as wrong output because it's not the way it is expecting. The way it is expecting is each one should be in separate line. Only then it may understand it. Now, if output is given like this, will it be able to understand? Absolutely no. So when we do something like this, our program or our compiler will of course give us wrong output as wrong values. So this is where you can get to see the difference and understand like which programs work well, which programs don't work well, because you need to print exactly the way it is asked. And the second scenario is that you need to follow all test cases. if you're a good programmer but you still miss out one or two test cases, if you still miss out a few test cases, even then your program goes wrong. So that's also not something we shouldn't do. So whichever language we choose, we have to print the output exactly as compiler asks. We shouldn't print anything else on the screen. We shouldn't even print like the output is or something like that, or we shouldn't print something like enter the input, or we shouldn't print something like please give me marks or anything like that. None of them will work because it's an automated compiler. It will only check for the right answer according to the logic in which the compiler has been created with. That's the scenario. So let's go ahead. I am able to see that nobody has figured out this logic. Nobody has figured out this particular like series, like what this series is made of. I'm going to give a clue. I'm going to give one little clue for all of you to figure out. Take this scenario as, look at only odd elements of the series and look at only even elements of the series. Does it ring any bell? I'll give you 20 seconds of time. Does it ring any bell? Only look at odd numbers and only look at even numbers. Let's see how many of you may possibly get it right. If none, don't worry. I'll help solve this. Alright, so unfortunately, nobody's got the right answer. Not to worry. I'll help you solve this. If you observe this, all the odd elements are exactly right. Now, one of you have got the right answer. Absolutely right. So, all odd elements are part of Fibonacci series. And all even, all even elements are part of Fibonacci series, because I'm talking about even index, not even value. I'm talking about even indices. Now, when you talk about all odd indices, all odd index elements are prime numbers. So it's not just like find nth prime number or nth Fibonacci number. They have mixed them both. They mixed them both and asked you to solve the problem. So if input is something like 4, just take a look at this. If input is, let's say, 1, 3, 5, 7, 9 or something. If input is 1, you need to find first prime number. If input is 3, you need to find second prime number. If input is 5, you need to find third prime number. If input is 7, fourth prime number. If input is 9, fifth prime number. This is what we are gonna solve. Similarly, if input is, on the other hand, 0, 2, 4, 6, 8, we need to find Fibonacci series. And Fibonacci series, we are starting from 0. According to this logic, we are starting from 0. So if input is 0, we are supposed to return 0. If input is 2, then 1. If 4, then if 6, then if 8. So we are going to start from 0 and we'll consider in our program this as our first Fibonacci number. This is our second, this is our third, this is our fourth, and this is our fifth. So we are able to find the logic. So for us to solve this, we need to do two programs. We need to write two programs separately. Remember, to solve this, we need to write two separate programs. One is to find nth Fibonacci number, another is to find nth prime number. Because just observe, all of these, whatever I'm marking in, I'm assuming it's looking like dark pink or light purple or however it is for you guys. So all of these, this will be my first prime number, second prime number, third prime number, fourth prime number, fifth prime number, and sixth prime number. So if user says, if user gives input 1, I need to find first term of the series, that is first prime number. If user gives input 3, I need to find second prime number. If user gives input 5, I need to find third prime number, and so on. So basically what I need to do is create a program to find nth prime number. That is one function we need to do. To find nth prime number, I need to create another function to find whether a number is prime or not. So we need to do multiple functions for this program, multitude of functions, but very easy logic will do that. Similarly, if you look at this, all of these are your, sorry guys, hold on. All right. So all of these are your Fibonacci series. If user gives 4, that's your third Fibonacci series. If user gives 6, 4th, 8, 5th, 10, 6th, and so on. You basically have to print Fibonacci series like this. So if you want, you can consider this as your first Fibonacci number, this as your second, this is your third, this is your fourth, this is your fifth. Because you can assume like 10 by 2 is 5, 8 by 2 is 4, 6 by 2 is 3, 4 by 2 is 2, 2 by 2 is 1, and so on. So we basically need to create two separate programs. One is to find nth prime number and another is to find nth Fibonacci number. So let's figure this out. Now remember, let's try to solve this. Let's try to create a top-down approach first. To solve this problem, to solve nth element of the series, I need two separate functions. One is to find nth prime number and another is to find nth Fibonacci number. To find nth prime number, I need a function which can help us to find whether a number is prime or not. So that's also something we need to do. So we need to first create a function which can find out whether a number is prime or not. Then we need to create a function to find nth prime number. Then we need to create a function called nth Fibonacci number. Then solve this problem. If you do top-down approach, start with main and then do smaller problems. If you want to do bottom-up approach, start with smaller problems and then do your main function. We're going to go for bottom-up approach because we know which functions to separately do. We're going to do these first, test them individually, and then go for our main program. That's what we're going to do. So for us to do this, I need to first figure out a simple program to find whether a number is prime or not. So let's start with this. Let's start with our C++ code. Again, I'll just write the question here. Find nth number of the following series. The series is like this. I'll just write this very quickly by looking at this so that we don't take up too much time. So 5 and 2 and 7 and 3 and 11 and 5 and 13 and so on. At Varun's question, I hope you were able to understand this entirely. I hope I was able to explain this in total. Now let's go ahead with the basic scenario here. I need to figure out how to find whether a number is prime or not. So we know this very easily. No problem with it at all. We already know how to do this. So let's do this very quickly. So again, since it's C++, I'm going to take it as int main. And I'm going to do something like a prime of something like 15 or whatever it is. I just want to create this function, nothing else. I just want to try it out. So I'm going to do something like prime of n, and I'm just going to do something like int n and c in n. We're just going to see if it works. We're just going to try to see if it works. We're going to create our prime function first. So we'll write here, this function returns 1 if number is prime, else 0. So since it returns 1 or 0, I can immediately say if it returns 1, the result of if condition will be 1, which means it is true. I can print, instead of printf, I can use cout and say prime slash n. That's it. Else, I can write cout non-prime slash n. That's it. So this is exactly what we're doing over here. Now, in this scenario, please observe this very, very carefully. In this particular scenario, I just need to find whether n is prime or not. Now, what is the logic to find if any number is possibly prime? To find if any number is prime or not, whatever number it is, we need to go through the following scenario. We need to, if it is 15 for example, we're going to start dividing it from 2 until 14 because a number is only divisible by 1 and itself. Now, if we start doing from here, we are missing out on test cases. What if user enters -1, -2, -3? We need to figure out all these scenarios as well. We'll do that later on. If user enters a negative value, how are we going to solve it? We'll do that later on. Now, let's quickly do this without taking too much time. So, I'm just going to read the number n. And we're going to use a for loop. For int I equals to I less than n, I plus plus. The number should only be divisible by 1 and n itself. It should not be divisible by any number until n from 2. So we're going to check if n mod I is equal to 0. That means if n is divisible by I. If n is divisible by I, if it is divisible by any number from 2 till n minus 1. You can also do this completely up to you. From 2 till n minus 1, if it is divisible, that means we will return 0, stating that it is not a prime number. It is only prime under one circumstance, that is for each of these number, for each I value, it will never go to this if condition. It is never divisible by any I value. So we will return 0 outside the for loop. Please remember, we are not going to return 0 using else. This we cannot do. We're not going to return 1 using else. This we cannot do. Because if we do this, it's going to give us a very wrong output. Think of this. If our input is 15, let's say n is 15, initially I will be 2. Initially I is 2. Is I less than equal to n minus 1? Of course it is. Now, since condition is 2, we'll go here, we'll check if n mod I equals 0. Is 15 mod 2 equal to 0? No, 15 is not divisible by 2. Remainder gives you 1. So, since this condition is not true, it goes to else and returns 1. It returns 1 stating that 15 is a prime number. That's not true. Just because it wasn't divisible by 2 doesn't make it prime. It's only prime if it's not divisible by 2, 3, 4 and so on up to 14. So, we shouldn't write else return 1. We should write return 1 after the for loop. If it is not divisible by every number 2 to n minus 1, it will not return 0. It will successfully exit for loop. That's when we write return 1 over here. Now, with this done, this is our brute force method. This is our brute force method which works in the most worst time complexity way. Now, as a couple of you have pointed out, if I have a number, let's say 1000, which is the biggest number lesser than 1000 that can divide it? Which is the biggest number lesser than 1000 that can divide it? 500. That's the maximum number, which is 1000 by 2. Similarly, when we try here, whenever I want to figure out if a number like 29 is divisible by 2 till 28, I should only divide it by numbers from 2 till I reach n by 2. That's it. So instead of using less than equal to n minus 1, I'll use less than equal to n by 2. That's the modification I'm going to do. Now, in such a scenario, our time complexity got reduced from big O of n all the way to big O of n by 2. This is a better time complexity. Now, I'm going to give you guys one more clue. This I'm not going to do it today because I want you guys to do some research on it. There are better time complexities than big O of n by 2 to find whether a number is prime or not. This is not the best time complexity. This is not the worst time complexity. We have better time complexities to work through this. So that's what we need to figure out. So this is one little question that I'm giving you guys today to think about this. So I have one of you stating yes, you also have big O of square root of n. You also have something lesser than square root of n as well. Not just square root of n, we also have something lesser than square root of n, which I'll explain in the coming session tomorrow. So do join in for that. Until then, take some time, scratch your head, think about it. What could have a better time complexity than square root of n? Think it through. Because we're going to solve that particular problem in the next session by using our best time complexity. And once you see that best time complexity, and if such a question is given, and you answer through this method, if anything related to prime numbers or Fibonacci series are given, and you answer through the method that we do tomorrow, you're definitely gonna get through unless you don't do it in quick enough time. So that's something I'm sure we'll be able to do by this logic. So let me just share the content here for your reference so that you can access it later on. So I hope you, this question sounds like something easy, but then again, it's not just about question being easy. It's about your ability to write or solve the question in the most time efficient manner. That's what we need to do. We need to solve our program in the most time efficient manner. That is what we're going to do in our session tomorrow. So do join us for our tomorrow's live session. Do keep checking Quantmasters YouTube link and subscribe and follow to get to know when the live session is up next. We'll continue ahead over there. So I hope you guys have had a fun time going through this session today. By tomorrow, do give it a check. Like, what could be a better time complexity than this? What could be better than root of n? Think through. We're gonna do that in the next session tomorrow. Until then, take care, have a good time, and